Welcome, everybody. I first want to introduce myself. My name is Eric Allata. I'm the coach, organizer with the CSNYC Education Meetup with Cindy Gao. We're sponsored tonight by Google, by the CSNYC Foundation, and we've got a lot of help organizing tonight's event. We've got a lot of help from Script Ed this week, so thank you so much, Script Ed. And we got a lot of help from Teals. Thank you so much, Teals. So my job tonight is to welcome you and to get this discussion started. Hopefully we'll get you warmed up, and then you'll start really picking the brains of this panel of folks to try to get a picture in all of our minds that it's a rich, complicated picture of what are all the different pathways that we can find for our students in computing. What are the evolving pathways? What are the unique skills that we can make explicit in our classrooms and in our after-school programs? And how can we continually develop that common vocabulary, right? And so a lot of us here tonight are not computer science educators. We are people that just work with students. And we want to know the student, know their skill set, know what we need to help them with, and know what the vivid potential, the actually concrete potential that they could have post-high school. Before we begin really diving into tonight's discussion, a couple people want to use you to make an announcement. They want you to use this group to let you know about some things that are happening. So a couple people want to make announcements, and they are, where's Ruthe? Ruthe? Yes. Ruthe Farmer from NCWIT, National Center for Women in Information Technology.
I'm so glad there's been advancements in AV technology. I swear, I've never been to an event where there wasn't an AV problem. It's ridiculous. So I'm with the National Center for Women in IT. I just happened to be here today, so I happen to be able to come here. So I want to tell you something since you're all working with students. NCWIT is many things. Go to our website, ncwit.org, and there's a lot of free things you can download in terms of resources for teachers to work with young women and to engage diverse populations in computing. But most importantly, every year between September 15th and October 31st this year, November 2nd, every young woman in the United States between 9th and 12th grade is invited to apply for the NCWIT Award for Aspirations in Computing. This award is available to any young woman who has interest or aspirations in computing or technology. So we are not looking for your very, 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 very best student that you're going to pick out of the group. We're looking for every girl who's interested in technology to apply. And the top prize, which we picked 35 of these, is $500, a laptop, and a trip to a gala award ceremony in North Carolina. But we also have 60 local events that are open to local students. So here in New York, they will be invited to a gala at Bloomberg. They will receive a bunch of goodies and lots and lots of things. Last year, 9 girls got a 4-year, $10,000 a year scholarship from Bloomberg out of this program. There are 46 universities that automatically award a scholarship to any girl who receives this award. So your girls should apply. It's just aspirations.org, grade 9 through 12. So any girl in high school. And please encourage all your students to apply, because even if they don't receive the award this year, they will get a whole bunch of other goodies and other support and rewards and things sent to them. I have a young woman here in the room who happens to now be an engineer at Venmo, she came up through our program several years, and there's a national community of girls that participate in this. So once they win this award, then they get inducted into a national community, and they get special things like special meetups with tech employers, special access to jobs, me recommending them for anything they want to do. So it's really a huge benefit. And it's a national community of about 3,500 young women across the United States that are in this network. So aspirations.org, every girl who's interested. And here in New York, in the city of New York, we will probably recognize 50 girls this year, and we also have programs in New Jersey and Connecticut, so spread the word. There are programs all over the nation. So aspirations.org, you can also just Google awards and girls, and you'll get there. Or Ruthe and girl, and you'll get there. So, thank you.
So next, Raquel. Raquel is with the software engineering pilot with the Department of Education. If you're not familiar with this, this is an incredible program that's putting software engineering programs into, like, they started with 40 schools. Wow.
Lower, a little bit lower.
So we had to scale back. Still, it's huge. Getting programs into schools and getting career pathways to students. So
that's perfect.
That's fantastic. Okay, sorry.
I'll keep this brief. You did a great introduction. We're in 9 middle schools and 9 high schools in all New York City. This is our 2nd year, so we're training a lot of software engineers, over 2,000 software engineers this year. And one of the things that we're just launching right now is a Pathfinders program. So speaking about pathways to careers, we're seeking partners to help us give our students some sort of experience, very low-key, 6 weeks, we pay for their experience in a tech company or similar company who's doing work in the tech industry, to have some sort of experience where they learn what work is like. We're calling it a mentorship program because they're going to be receiving a lot of guidance from our staff about what it's like to be in the workplace. And we're hoping that this will be a very much project-based experience, very much like their curriculum, which is all project-based, and they learn a lot of skills, including web development, so they're very highly skilled, even though they're 9th and 10th graders. So if you're interested, we have these forms, say Pathfinders program. They're at the table outside. I'll also leave my card. So feel free to contact us, and thank you for your time.
Is VidCode here? We wanted to hear an announcement.
Do you know anything about VidCode yet?
No, I'm not going to say anything.
Okay. So VidCode is very new, which is why Eric might not know about it. But thank you and Cindy very much for the opportunity to talk to you guys today, because this is a really crucial time for me and VidCode, and you guys still don't know what VidCode is, so let me tell you. VidCode is an online platform designed to ignite girls' interest in computer programming through video. So it's a platform where they can upload their videos from Instagram and all the places where they're taking videos, and actually learn to code different effects and visual effects on those videos using JavaScript. So it's just a really nice way to get girls, kind of give them an entry point to learning code. And actually VidCode was born about 8 months ago, when the last time I saw Ruthe at the last CSNYC meetup focusing on women in computer science, and for the last 9 months we've been working with the software program computer science pilot here in New York City Department of Ed schools, and been prototyping and working with hundreds of girls on this platform and perfecting it. And today is the first day that we launched a Kickstarter to accelerate the development of this platform, because we've had a lot of really great feedback from the Girl Scouts of America wanting to do use our platform in their workshops, and from schools themselves that would like to have a curriculum. So we would like to take what is currently a prototype and really build a full JavaScript coding curriculum for those people. So it's VidCode, VID as in video, COD, and I encourage you guys to check it out with your students, for yourselves. Like, it's just a free online portal right now, and I would love for you to just kind of take a look at it. I would love any feedback from your students. Like I said, it's designed for girls, but certainly for boys and anybody who's sort of looking for a new entry point to learning code. So I would love for you to check it out, and feel free to reach out to me and support the Kickstarter if you feel like it. Thank you very much.
Welcome. I just wanted to do a quick introduction of the who we are and what we're going to do before, and then we're going to just dive right in. I'm looking out across the room, and this is really exciting. What I'm noticing is that a lot of people are here for the first time. So will you raise your hand if you have not come to a CSNYC education meetup yet? That's really cool. That's really cool. The rest of us, I see a lot of regular faces, right? So Tracy, I love your t-shirt, by the way. And
someone bought it for me yesterday at Makery.
Tracy has been posting all these Maker Faire pictures, and they're awesome. Thank you. So a lot of teachers are active on like Google Plus and Twitter, and like Kelly is always putting out like a live tweet of our events. And so find us on those online communities as well. So the CSNYC is a foundation for expanding computer science in New York City. The goal is to get computing education into every classroom of all 1.1 million students into the city within the decade. One of the first projects was to start a school dedicated to computer science, and that's the Academy for Software Engineering. So I'm really fortunate to be one of the computer science teachers at that school, and that's how I got to be involved with CSNYC and their projects and meet all these other people. So tonight, what I'm really concerned about is I have every kind of kid you can imagine in my classroom. I know I've got just every background, every skill set in there. And the reason why we need to come together, the reason why a school like mine was created, is that computing hasn't been all that diverse. And it's you had a skill set and you could apply it to what was out there, and then you found yourself in computing. But now that's changing. Now there's an exploding environment of pathways that people are finding all these different inroads into careers, and that's what we're going to find out about tonight. And we're going to then be able to translate that into our students. What can I do in the classroom or with my student? What's the actual skill that I can help them with that will help them to define that unique pathway for themselves that might not have been ever done before? They'll be defining it for the first time. All right, so I just wanted to start with introductions. Can we just go down the row of our panelists, and would you tell us your name, and then can you give us the 30-second, what's my role and how did I get there? Try to pack it up for us in a bite-sized piece.
Sure. My name is Kent Rahman. I am the head of user research for North America for a company called ThoughtWorks, which is a design software consultancy. So user research field that really wasn't around. It's a relatively new field, so I actually don't have any formal education in design or technology, which makes me wholly unqualified for my job. But no, I was interested in computers at a young age, but when I was trying to decide what career to pursue in university, I thought I didn't want to sit in front of a screen all day. So why would I want to do computers? And then when I got my degree, I realized that everyone's in front of a computer anyways. And so out of college, I actually did my degree in economics and history, and realized that really wasn't for me. So I got a job at a record label and really didn't like it, got fired, and I was amazed at how much that's a motivating factor for finding a passion and a career that can sustain you for a long time. So I started building websites for my friends, and anyone and everyone who needed a website did that for free. Built up a portfolio, started a consultancy on my own with a friend of mine, and then that one thing led to another, and I found myself in the job that I'm in here today.
Hello, everyone. I'm Baris Yuksel. I'm an engineer at Google IDS. I work on a project. I lead a project called Project Shield, where we're building a system that protects human rights and freedom of speech organizations against cyber attacks. I am here on this panel because last year I happened to volunteer with ScriptNet, and I thought, with no formal education background, no teaching background, I thought a classroom of 8 kids at Cristo Rey for a year, and with great aspirations, but we came to where we came at the end of the year, and I'd like to talk about it later on. But my story is that I came to this country not speaking English when I was 18 to get college education at a proper American college, which was really tough. I failed a bunch of classes because I couldn't understand what the teachers were saying. In fact, I didn't know that there was homework. I didn't know what homework was. I mean, I knew what homework was as a concept, I just did not know the word. So, but anyway, so I, when I talk, try to teach these kids, I try to I kind of understand where they're coming from. Like I tell them about a for loop, and for loop for me is like so straightforward, but they're like, for loop? Why would you loop? But anyways, regardless, so yeah, happy to be here.
So you got into computer science because the classes weren't in English anyway?
Yes, that was easy.
My name is Doug Rohde. I'm also here at Google now. I manage a team that builds the main search engine, so it's all the infrastructure behind the scenes that answers your questions. But I kind of got into it through a slightly circuitous path. I started out learning to program BASIC in 4th grade because my dad worked at IBM, and that was the thing you did back then. But computers weren't quite as exciting back then as they are now, and I really didn't do much in computing through all of high school. Some of my friends took AP CS, which was like write a banking transaction system. It seemed totally boring to me, so I didn't want to do any of that at all. But then when I went to college, I took a real programming course and just kind of fell in love with CS. And at the time, I didn't know really what area I wanted to go into. I was thinking about environmental science and brain science and a lot of other things. But I realized that with a background in coding, I could go deeply into any variety of area. And I ended up, sort of staying in computer science, although I did a PhD in computational neuroscience. So we're working on building neural network models that try to simulate how the brain learns language as a way to understand how the brain works by building models and seeing if they behave like kids do, or undergrads do at least. But by the end of that, I was getting kind of sick of academia, and a friend of mine said, why don't you apply to Google? So I did, and kind of fell in love with Google. So I've been here about 10 years. But in addition to my day job, one of the things I do on the side is work on our community affairs committee, which does partnerships with nonprofits and government. And I kind of focus on education. So I've been one of the advisors to AFC and work with Camp Interactive and a bunch of other folks in the room. So that's how I got here anyway.
Hey everybody, my name is Omar, and I'm a junior QA engineer at Nomorerack. It's an e-commerce startup, and I never had like a formal background in computer science. I kind of only learned how to code because it was a requirement for my major in school, and I was a math major, and I've always kind of been like a math geek. But then when they made me take a computer science class, I fell in love with it because math is fun when you do it by hand, but computers, really make it 1,000 times more interesting. And that's a lot because I thought math was super interesting. So adding that
extra flavor, it was just just blew my mind. And I remember after taking my first programming class, I applied for a QA internship at Guild Group, and I was lucky enough to get it. And it was QA is software quality assurance, an emerging field, and they were talking about there's a lot of demand for it, but everybody who likes to do that, not likes, but everybody that's good at QA, they don't stick with QA. So you should really take a look at that. And I was all right, cool. I think I'm gonna try to help fill this demand. And after I finished school, I just applied for probably 1,000 jobs, and then I was lucky enough to get a position at Nomorerack, and I've been there for 6 months now, and I love it.
Hi, I have a loud voice. My name is Sarah, and I work for Bank of America Merrill Lynch. I work on the investment banking side in a front office technology role, so that's with sales and trading. So how I got here was also a circuitous one. I failed out of architecture school after 2 years of investment. That's a long time. So when I was a junior, I decided to do computer engineering because I wanted to go into scripting, architecture, or something. So as a 20-year-old in my Comp Sci 1 class, I realized that I couldn't program. I spent 20 hours a week learning how to program and going to every single office hour, talking to every single professor, and still barely making it through the class. So Yeah, my confidence was pretty low, like several years later. My classmates were all younger than me, and I was asking everyone for help all the time, but I was never scared to ask because I just knew I had no choice but to pass. I had 2 other younger siblings in private university, so I was like, for the sake of my parents, like I have to like pass school. So when graduation came around, I just knew I had to get a job, and that was my only choice. So despite not having the passion for finance, I ended up here. And I'm so happy that I ended up failing out of architecture school and having some hard skills in computer science, even though I'm not the best programmer today. But yeah, I really like it now.
Hi, I'm John Santiago. I'm kind of a technology educator. I started a co-op of tech educators called TAPAD. We work with schools and museums, set up CS classes and maker spaces. And we also have a project called the Makery, where we set up, we turn retail spaces into pop-up maker spaces, and we hope to eventually have our own permanent space in the city. So I got into tech. I was really fascinated by quantum computers when I was 18. I had read Ray Kurzweil's book, The Age of Spiritual Machines, and drank the Kool-Aid of the singularity idea. I'm like, wow, quantum computers, like that's next, that's gonna happen. So I worked for this gentleman named Neil Gershenfeld, who was co-founder of MIT's Center for Bits and Atoms. So I worked as an undergrad and worked with some grad students who were pretty disgruntled about the future of quantum computing. But we did have laser cutters, and we had a water jet cutter, and we had all these cool CNC tools, and there was this outreach project called Fab Lab that I got involved with. And I didn't really want to do academia. I found that before I went to grad school that I didn't want to do academia. But I really love to play with things like laser cutters and microcontrollers and electronics. So I helped set up a Fab Lab in the South Bronx with an organization called Sustainable South Bronx that was focused on environmental sustainability and urban revitalization. And then after working there for a couple of years and doing an NSF grant that focused on teaching digital fabrication and physical computing to high school students, I started our co-op and have been working throughout the city to create more maker spaces and create more CS programs.
Hi, I'm Sasha. I'm a software engineer and data scientist at a very small consultancy called Polynumeral. We're so new that our office is under construction right now, and we picked our name last month. So I'm one of 4 people. I was the second person hired. I really like being on early teams at organizations. I actually started out, like everyone else on this panel, have a circuitous path. I taught high school physics and neuroscience for 5 years, and then realized that I just didn't have the patience for it. I really like having an idea and executing it immediately, and not waiting until the 2-year cycle is up where we alternate with microbio or whatever, you know. Like I had course ideas and I wanted to do them right away, and teaching just wasn't the right cadence for me, but I did love it. I was out in San Francisco at the time, and so I saw some interesting things happening in the tech world around me. I took my first programming class when I was 15, but it was incredibly boring. It was in C++, we were formatting restaurant receipts, and I was like, why would I do this when I could do physics? And I went off and did physics and majored in that. It was not until college when some of my friends were like, hey, look at this cool urban rescue robot I'm building in my CS major, and I was like, damn it. It's too late to switch now, but I sort of had inklings that it was pretty interesting. And so when I was like, okay, teaching isn't working out, I don't think I'm in it for the long haul, what else can I do that's interesting? What else can I contribute to? And I started asking around in the tech community and found that there was a lot of interesting stuff happening there. And I started moonlighting in my last year of teaching, helping a very, very small startup with an iPhone app that was to teach teenagers financial literacy, kind of like Zynga style, like Zynga for good instead of Zynga for money sucking. And that was awesome. I learned a lot. I worked alongside the CTO. I got to play test with teenagers. That startup did not make it, like many startups. I ended up working at a medium-sized startup and learned a lot about how businesses work, which I had no idea how they worked after teaching for 5 years. And then I ended up at Code Academy here in New York, and that's why I live on the East Coast now. And I worked there for roughly their first year or so. I ended up leaving and going through this amazing program called Hacker School that is not really a school because it's more like a retreat for programmers. It's 12 weeks, it's free, I can talk more about that later. Yael is also a graduate of Hacker School. And that was amazing, that really jump-started. I did about a year of learning programming in 12 weeks. It was pretty remarkable. And then I freelanced for a bit and tried to figure out what direction to charge off in, and I ended up really enjoying data science. It's a confluence of math, of understanding people and insight and programming, and there's a lot of power, and I'm really curious to see whether society handles that power responsibly or not in the next few years. So
So I'm Yael Elmatad. I'm a data scientist at a company called TAPAD. I like to say that you've never heard of us, and that's the way we like it, because we're an ad tech firm. So if you had heard of us, it'd probably be some gross scandal or something. Not really. So I'm glad that none of you have heard of my company. I'm going to tell you a circuitous story about my circuitous path. So I've been teaching TEALS now for a week, no, 4 weeks, and I did this exercise with my students because I was told I have to engage them. So how many of you are teaching right now? High school is great. How many of you, could you keep your hands up, how many of you, does this describe the majority of your students? Their parents are immigrants. They don't speak English as a first language. Their parents didn't go to high school. Their parents didn't graduate, from college. Their parents, they go to New York City public schools. Yeah. So that's my story. My parents are immigrants. People always assume because they're from Israel that therefore they were educated and fancy, but actually they're fairly math illiterate. They couldn't help me with my homework. I'm the oldest child. So I really had that to go it alone, and I had a lot of really, really great teachers that helped me along the way, and so as a way to give back, I've been doing TEALS. But aside from that, my first love is actually chemistry, until I realized that my flat feet meant that I couldn't stand all day during experiments, and my clumsy hand-eye coordination meant that I broke too much glassware. So it actually costs the lab too much money to keep me on, and so I had to find a new way to do chemistry. And at the time, I was being pushed towards computer science, and a lot of people, were pushing me in that direction, and I was really actually pushing back because I was like, oh no, that's too hard, I can't do it. Statistical physics, that's cool, like no problem, but give me a bash prompt and I go a little crazy. So eventually I had to acknowledge the fact that if I wanted to do chemistry, it was going to be computational. And so I went that route, and actually my CS professor is here. It's Evan, who's right there. I took a year with him, and by that time I also realized it was too late to switch to computer science, but I did end up going through the minor. And I ended up going to grad school, and I got a PhD in statistical physics. I did a postdoc in statistical physics, and then I did hacker school, thinking I was going to go learn about high-performance computing, and what I actually learned was, oh my god, there's this new field called data science I didn't even know existed. And that's sort of how I ended up being a data scientist in a very weird way.
Okay, those are all really tough acts to follow because my trajectory is in some ways much less interesting. So I enjoyed 12th grade, and I enjoyed 16th grade, then I enjoyed 21st grade, and I'm pretty much in 36th grade now. So in some ways, my trajectory is pretty real linear because I never left academia. So my day job is I'm a professor at Columbia University. One day a week, I'm the chief data scientist at the New York Times. I will agree with the last two speakers that data science is very interesting, and it's a very interesting time to be in data science. And then I'm also a co-founder of HackNY, along with Evan, who's previously mentioned. HackNY is an experiential education program. We have a structured internship program called the HackNY Fellows that we run every summer, bringing full-time students to New York City. These are college and graduate students to New York City to work in startups. And they live together and then teach each other at night, which I think is a really important form of education, is trying to create an environment that facilitates peer education, which scales far better than Sage on the Stage, in my experience. I have also tried to teach a lot to people who are not coming from a hard science background. So for example, this summer I was teaching in Columbia's journalism school. I was one of the people who co-created this program called the LEAD program. So if you go to github.com/lead program, you can see our curriculum, which is based on introducing people mostly in Python who are not coming from a computational background at all. Most of these people are journalists, so they're smart people, but they're not coming from a computational background, and introducing them to databases, algorithms, data science, and what have you. In terms of how I got to be this way, I am an applied mathematician with a PhD in theoretical physics, applying machine learning in biology. Although I stayed in academia, I had a pretty circuitous path between, liking BASIC, like many of the speakers in the 70s, so I could program games with my brother on a TI 99.4a. And then going to physics for undergraduate and for graduate school, so not doing CS as my background, but always being very computational. So I'd say 1989 through 2001, I was solidly writing Fortran for scientific computation. So, although not a CS background, I've been doing scientific computation since the 80s. Big fan of the shell script, also mentioned. And then at the end of my PhD, a lot of my interests were more in how you take the style of modeling from physics and apply it to biology, which in the 90s, biology sort of became a data science. We'd now call it data science, but basically the field became very data-driven and very computational. And so at that point, I became an applied mathematician, was at NYU, and then I started a faculty position at Columbia, and now my work is, as I said, in a field we would now call data science.
Thank you, everyone. I'm hoping we can spend a little more time on obstacles. So I thought, I'm really glad we heard, I didn't know the word homework, or my parents didn't know math. What are some more of the, I had to deal with this, and why did you stick with it? Why did you push through, and what was something really, really challenging?
It's a very sad story I'm going to tell you right now. My first love is not chemistry, it's actually math. And when I was 15 years old, I got put in a special math class, and I was the only girl in the class. And I went from having the highest score in the SAT as an 8th grader in the state of New Jersey to being the worst in this class of 15, really fast. And my teacher couldn't handle it. Couldn't handle having only one girl in the class. The other kids couldn't handle having only one girl in the class. It was something that, it really took me off track. All my life I thought I was going to be a mathematician. Here I was 15 years old in this very advanced discrete math class, and suddenly I was failing. And it really showed me that, I thought I was this strong woman, I was smart, I was capable, and it showed me just how easy it is for someone who's smart and capable to really have a hard time and struggle. So it's really important for me, and one of the reasons I teach now, to show girls that there are other girls around and to protect them from that. And not just girls, but all minorities and all diverse groups. And that's something that I didn't really overcome until I went to college and I wasn't the only girl anymore. And then finally, when you get to be 19, 20, that stops affecting you as much. I mean, not completely, but not as much. So it's not really an overcoming of the challenge. I never really overcame it. I kind of ended up being diverted. And I think that's what happens to a lot of people. They just end up being diverted. And luckily for me, I could kind of find my way back. But everyone doesn't have that luxury.
I also have had numerous people in the time between teaching and now try to divert me into less technical fields like product management. And it's taken a lot of, every time someone does that to you, and it happens a lot of times, it makes you really question whether you belong and whether you can actually contribute. But I was able to surround myself with enough people that had faith in my abilities and encouraged me in the right direction, and kept me honest on that. That was really helpful to keep going and to actually get into the code. Ironically, also, I found that being a really good student was unhelpful to me in this career in a way that I didn't see coming. It really blindsided me. It did great for getting me through high school and into a decent college and through college, but being good at checking things off a list and reading all the chapters in order and doing what the professor says actually doesn't transfer over super well to a field where everything is changing every year, and where no one is going to hand you the next thing to do. You need to go take it. And so particularly learning technical skills, there's a lot of times where you just need to sit through a lecture and be confused and sit with it, and then you will get it. But you won't necessarily get each step in order. And those are things that I didn't learn in school. I don't really know how I could have learned them in school, but that's your jobs, right? So that is a feeling that, a thing I've had to unlearn since getting into the tech industry.
Yeah, it doesn't have to be everybody. Any good, more obstacles for us?
I have an obstacle. I guess all the women are speaking here, so I'll join in. So, as I told you guys, first of all, I already failed architecture school, so my morale was pretty low. And then I switched into this major that I didn't know anything about, and I thought I had made a good decision based on like types of careers that people got. But then I took my comp sci 1 class and I was like, oh my God, I actually really can't go through this. So I have a decent work ethic. I went to every single office hour, and I actually feel like I didn't gain my confidence until I started working. So kind of the opposite of what you just said, Sasha. I did not do well in school. I went to like every single office hours. I annoyed so many professors that they didn't really give me the answers per se, but they had to get through like certain students. So I think they would kind of give me the answers, or kind of like basically point me to a direction where I could pass the class or like get acceptable grades to get a decent job after college. So it was only after college that I realized that I do have a good work ethic. And like Sasha said, technology is always changing. And that's something that I was able to kind of, like, you don't need to understand everything deeply, but you need to understand the direction where it's going and be able to grab the next thing. And that's where, I guess for me, like, I didn't have that opportunity in college. So that was a really big obstacle. Trying to find a job when you have like a low GPA, when you have no idea that you have any skills in the major that you just did. So it was kind of like fake it till you make it, and that was really, really tough for me, because like how would somebody else hire you for a job if you don't have confidence in yourself? They just fake it, and I faked it, and now I have a job. It was
When I first started working, when I started working, I liked coding. So coding for me was like natural. But the thing is, I did not understand the code that I was supposed to work on. And I got really intimidated by that. I felt like everyone around me like understood everything that was written on that, header file or C++ file. I'm like, wait a minute, I really don't get it. Like, I really don't understand this code. And then I felt very stupid, and I felt very, very, very stupid. And then I felt like, maybe it was a disaster, or it was going to be a disaster working there. I didn't start working at Google. I was working at Microsoft at the time. Nothing to say about Microsoft's code. I'm sorry, that's not really. But what I'm trying to say is it's like I really did not understand what these guys were writing about. And I did really horrible. Like first years of my career is I was waiting to get fired because I didn't understand what this thing was about.
So I can add one too.
You want to add one more? Go ahead.
Yeah, sorry if we perpetuated a gender stereotype. I didn't realize that was going to happen. So, yeah, I had the same issue. When I started, I felt I was fairly intelligent. I didn't do much CS in high school, so when I got to college, I got destroyed. Just honestly, luckily, there's a system at MIT where it's pass-fail your first year. Otherwise, it had some really bad. Lyle back there went to MIT, also knows that. So yeah, my self-esteem probably still isn't recovered, but it's a long-term project, So I think what really helped me push through was just putting everything into context, right? I definitely went through a bit of a Marxist phase when I was in my early 20s, which I haven't quite grown out of completely, but I've accepted market-based systems for making the world a better place. But a lot of people who are really smart don't make the world a better place, right? So you have to sort of take everything with a grain of salt. And I just really pushed through because I'm like, well, these are tools, right? Tools can be used to make the world better, or they can be used to make the world worse. I just really wanted to push through, not just for me, but for trying to make my time on Earth sort of valuable. So,
Just real quick, I want to piggyback on what Baris said. That feeling of everyone's going to find out I'm a fraud any minute, I don't belong here, everyone else knows more than me. That feeling is so common in our industry that we're talking about it now under the term imposter syndrome. And there's been a lot written about it recently, and almost everyone feels that way. So strategically timed affirmations that you do belong in this place and you are good at it and you will learn it even though you're struggling now can go a really long way towards helping someone through that and keeping them in technical fields.
Thank you for that, Sasha. I think that's that's the kind of thing I'm looking for, where I want to have I'm actually building a teacher checklist in my mind of what do I actually need to do. And I think calling out and naming something imposter syndrome, everybody has it, and then actually planning when I'm going to give an antidote to that, first period to this week, and then do it again next week, and then do it again in a strategic way. That's really helpful. And speaking of teachers, now, I do have to get into what your actual roles are, what you do, and I want everyone to understand more about this industry. But before we do, if you're successful people that just would have been successful no matter what because you're brilliant and beautiful, that's okay. But I firmly believe you probably had a really good teacher along the way. And could we hear a couple of stories of this person really did this for me, and because this person did this for me, I was really able to make a different decision or make a different choice or stick with something longer than I probably would have.
There's like 12 of them. So, but part of going to school for so damn long is I benefited from having fantastic mentors I've had like 12 really great mentors at various points in my life. So my high school physics teacher at like generic public school in Texas was fantastic and encouraged us all to do lots and lots of experiments, which, when you think that school is about the following. In September, I tell you how to integrate 1 over 1 plus x squared, and then in December, you tell me back how to integrate 1 over 1 plus x squared. It's just soul crushing. So it was really liberating to have a teacher who was like, here's some lasers, let's make a hologram. Let's do some crazy stuff with physics. And so I've had consistently good mentors throughout, and the effect of that is I really know what it's like to have a really good mentor. I really know what it's like to have a really bad mentor. And I really want to, perpetuate and create good organizations that create good mentoring. And my mentors have not always been scientists. I had a really good, I've had really good liberal arts professors as well that, encouraged me to not be so monochromatic in the way I was going to think about what I bring to a community, which I think is very useful because one of the things that you hear, or that we've heard, certainly through HTINK, we have a lot of lectures from successful software engineers, and many of them talk about the importance of not just their skills as a software engineer, but leading a team, expressing yourself, listening to people, all of those other aspects of being human, will impact and give you a richer career and richer life.
I've seen the research on math, and one bad math teacher can really knock a kid off track for the rest of their education. And so I feel pretty grateful to have an unbroken string of awesome math teachers. Shout out to PS29, if any of you are teaching PS29, that was my elementary school. And that enabled me to finish all the math I needed for a physics degree in high school, which was pretty rad. And my sophomore year, I took honors physics, and Mr. Daniels at King Lab Middle School, it was my middle school, at ETHS, Evanston Township High School in Illinois. He showed me that physics was fun and cool, and you could do cool things like shoot a dart at a monkey and using math, and I just thought that was so beautiful and interesting, and that really got me excited about every class with him was super fun and exciting. So don't ever forget that part. It's really important.
So when I was 14, I went to a public high school in Florida that was a multimedia magnet high school. And I remember there was a theater teacher who knew nothing about computers or the video, but he got assigned to be the TV production teacher. But he had a grant and had all this Adobe After Effects software and Adobe Premiere. So I remember on this Pentium 3 computer, he let me just spend all class and after school just playing around with video editing, and got really interested in computers. So it kind of speaks a little bit to VidCode and the power of getting people interested in computers through video editing and doing kind of processing. I think that experience, for a couple of years doing kind of creativity with technology really has informed the work I do with young people, where I try to give them the space to kind of explore and only create structure where it's needed. So I think that mentorship, that I had from that high school teacher really has kind of motivated my work.
I don't know how many of you guys in here have seen the documentaries Waiting for Superman or Saving Superman. Nobody? Oh, okay. All right, cool. I'm not an educator, so I don't know. I feel cool for knowing it. But so I went to a high school where it was a higher performing high school, and I was one of the students that was in the middle, so I wouldn't really get that much attention. I wasn't failing terribly enough where teachers would be coming to me trying to help me, and I wasn't a high performing student either, so they just kind of let me be, which was kind of hard because I just didn't have that much confidence because there were so many students that were really high performing, and then again with the architecture thing. And finally, when I ended up switching into engineering, I scoured all sorts of internships, professors that needed help, and I found one, and I figured that there weren't that many students applying for it, so hey, it's probably my best chance. And he accepted me, and my job was for being his professor's assistant for a class called Introduction to Embedded Control, where students would program microcontrollers with using C programming, which was cool because it was like an application class. It was a class that I had already taken. I don't know if I could have been a TA for that class, but through that experience, it made me realize that even though you don't know things, and even though I didn't even know the curriculum, even though I had just taken the class a semester before, that when you're under like certain situations where you have to teach people and you realize that you're responsible for other people, it really motivates you to like know your material and be able to teach it. And at the same time, you can never be prepared enough. So if you don't know something, I would feel comfortable being like, you know what, let me go back to my computer and try to figure it out, and I'll come back to you. And I'm also in TEALS, and I think that it also helps me through this experience with trying to teach other people within TEALS as well.
Can you repeat the question, please?
Tell me a story of a teacher that helped you choose a pathway or overcome it.
We have to be like an actual like professor.
No.
Okay. I know for me, like my biggest mentor had to be like my old boss at like my second internship. Actually, at each of my internships, I think my bosses would be like my best mentor, because like in every internship that I had, the QA department was relatively like small, and they would always like express the need for QA, and I as an intern felt like very lost, but and asked a ton of questions, and I know like at the end of the day, my bosses would always say, "Omar, you know, you're doing a great job," and I would say, "Yeah, right." Although I would always feel lost, and they would give me work, and I would do the work, but with like very little confidence. But then at the end of the day, when they'd say, you know, "Omar, like you might have a knack for this," you know, that like pushed me, and towards like my last internship, when my boss, you know, like tried to hire me and everything, I don't know, I felt like pretty happy. So like, you know, I went back to school, big smile on my face, and I don't know, I kept in contact with him and everything. And then as, you know, I applied for like that position and like a lot of other positions, you know, he gave me like all of like this interview experience. He said, you don't have to come back here, you can go like over there if you want, like to anywhere you want. And I don't know, I just feel like having like my old bosses as like contacts and having them, you know, help me explore like uncharted territory, that helped the most for me.
Omar, can we stay? I'm sorry. I want to push us into more about understanding what you all actually do every day. And I want to start with Omar, because I'm really interested in quality assurance and what that looks like. And then what I'm hoping is we can hear is what does it look like? If we could take a video of you and then do one of those speed it up or like a stop motion camera thing, like what do you do all day? And if you don't like your current job, can you pick your favorite job, or pick the job that your dream job, or just give us a picture of what does it look like to be you doing this job that you really love?
All right, so well, QA engineers, they vary from like firm to firm, but at my job, I run the gamut from a tester all the way to like an automation engineer. So like that basically means that like when we have new software that needs to be released, and we release software we push code every single day. Before we release it, I have to sit there and I have to test it. And now there are two ways to test it. You can either, you know, manually go through, click everything, and, you know, look at the test cases and see whether or not it matches the requirements. And or you could use like tools like Selenium or whatever to like automate this whole process. So like I'm their very first QA person. So I have to do like all of this stuff. You know, from manually testing it to like writing all the automated tests. So on a given day, I probably write like a test or attempt to write a test or two, because we have a lot of like things to test, and there are like 10 developers, and I'm the only person on like the testing end. So I write maybe like a test or two a day automated, but then I also have to like run through and test the most important parts of all of our software to make sure, we're charging everybody sales tax and things like that.
Sure, I'll tell you a little bit about what I do. When I first started at Google, I was pretty much coding 90% of the time. And back then I was working on our question answering system where if you ask us some factual question, we will try to give the answer right up front. So that was a bit of algorithms, a bit of kind of AI-like stuff, but a lot of just system building. But I've now over the years transitioned into doing much more management. So I manage about 30 people. So my day is about 90% walking around talking to people, and a lot of what I'm doing is just strategic planning, problem solving, helping them design things, and I do a lot of writing of design docs of the next part of the system that we want to build, or understanding a problem that we have. And I still get my hands dirty a little bit in coding and code reviewing and that sort of thing. So it's fun because it's varied and it's very social. So one of the things that you learn when you get into industry is that coding is a small bit of the job, and a huge part of the job is communicating and planning and working with people and being a great team member.
A lot of nods on that one.
Well, I spend 50% of my time coding right now, and I started like 90% coding in the beginning. I have a small team there's only 3 of us, and I help them design the system. We have to communicate at all times. I really emphasize on talking. This is what happens. I've observed this I've worked on 3 teams so far at Google, and every single team, in order to innovate, they have to talk at all times, and that means a lot of interruptions during coding time. So imagine like 5-6 engineers just coding and talking. That talking, if it doesn't happen, innovation doesn't happen, because what I observed is innovation happens when person A talks and person B says something to it, and person C adds on it, and person D says, "Oh, I saw a pattern right there," and then that happens. Some other percent of my time I'm spending trying to motivate CS students. I go to hackathons at colleges and I try to talk to them about doing social good projects. For the first time in the history, software engineering has an opportunity to change lives for billions of people who are below the poverty line, the $2 or the $1.25 poverty line. In 2009, Kenya got fiber, and now Africa is all getting connected. So software engineers not only have to, traditionally there are 3 options. You go to a startup, or you work at a corporation, or you stay in academia. For the first time, we have the option to really save the world. And so I spent some time just doing some grassroots for that too.
So my job is pretty simple. It's to make sure that the software that we design makes sense to people. That's basically it. Surprisingly difficult to do, as most of you probably know, being frustrated infinitely by the software available today. So user experience, it's a field that is relatively new, hasn't been around for a long time, but there's a tremendous value to dedicating time and resources to understanding the way people who use your system perceive the world and what their mental models are and how they go about integrating the software that you provide them into their daily lives. Most of my day is spent talking to people. It's going out into the field doing what we call ethnographic research, talking to the potential target people that we're releasing software to. Spent the last couple of years in classrooms, speaking to teachers, talking to students, administrators, trying to understand how they use software, what their frustrations were, what was working and what wasn't, in order to try to build an educational learning platform. The other part of my day is spent taking those insights back to the development teams, the product managers, and communicating them back to the team, essentially. and ensuring that in the development process, the needs and the desires of the users are being accounted for. And I spend a lot of my time designing, informing the design process, sketching, and building user interfaces, which is the part of the software that you actually see. Taking the insights from interviews and from actual users and incorporating that into the design of the software itself.
Let's hear from everyone on this question.
This is actually a question I really don't like answering. I had to write it down so I could prepare a good, well-versed answer. So I wrote down for myself, manage long-term initiatives while responding to immediate emergency risks. So, Bank of America Merrill Lynch merged in 2008, and they still have very separate systems. So examples of some short-term risks are, I work in emerging markets, so that's like Latin America, Central America, Africa, Eastern Europe, so all these places that don't have like a very established financial markets. So like for example, when Argentina went into default, I have to know what to do. Everything is data driven, so like where do these trades go? I have to understand the trade flows and respond to that immediately. Or when there was the sanctions in Russia, I have to understand what does that mean for technology. So I guess we all know sanctions as, oh, we can't buy certain things from there, we can't trade certain things. So from a technology perspective, it's like, okay, who are these counterparties and like who do we send them to, and like can our systems handle this? So those are some of like the immediate risks that I had to handle. But when I mean manage long-term risks, it's not like, I'm not a project manager, I'm more of a business analyst. So in order to tell developers how to make our market-making applications better, or to like provide a better trading experience, they don't really know what to do unless I kind of give them specific specifications, like here are the inputs and this is what's supposed to happen. So yeah, I would say I do like 10 to 20% of my day coding, because I do have to debug code. Anything that happens in our front office suite of applications, which the traders and salespeople use, if there's any problems with it, I'm the first point of contact. So I literally get disturbed 80% of my day, and it's just managing those small things. Whoever's yelling the loudest is usually the one that gets the most attention. So it's just kind of managing what kind of tasks to take care of first, and what are understanding what the most, I guess giving good deadlines as well, because everything is always urgent. No matter who he's talking to, everything is ASAP. So yeah, that's, I guess, if I didn't say this well, please speak to me after, because I would like to I would like to know how to tell people what I do for work in the future.
So one thing that's a blessing and a curse is that, for me at least, is that no 2 days of my week are the same, just because the nature of our work is to go out to different schools, working with different age groups, also kind of sharing with the administrative load and dealing with kind of just managing the day-to-days of a small business. So one thing I've actually been really kind of inspired by, and I've been trying to push on my colleagues, is the Pomodoro technique. Has anyone ever heard of that before? In the room?
No,
you should, yeah, Google Pomodoro technique. So, yeah, it's you know, it was getting kind of frustrating for me how different my days were, and how much difficult it was to process information. So I would try to do so many things at once, and then sort of not doing it, sometimes not doing anything. So the Pomodoro technique kind of focus, like you get to wake up in the morning, plan how many Pomodoros you're going to do, right? Like 25, yeah, line up like a little egg timer. So on days when I'm actually out teaching, it's like not so much of an issue, but doing the admin stuff, we're figuring out new clients that are and collaborators that my organization is going to work with, dealing with like a real estate hunt, which we're in the middle of doing for our our makerspace. And of course, bookkeeping, accounting, and all that stuff. So basically, given the whole realm of being like cooperative technology educators that works together to do all this stuff, each one of my days is a little bit different. So.
My day is also fairly varied, as I'm also in a smaller organization and do more entrepreneurial stuff. And I hadn't realized this until just now, but a large percentage of being successful in my current role is managing distractions and incoming information. And this is a skill I have seen very few high school students succeed at. I'm sure you've also seen the same thing. It's actually a skill because these products are designed to be addictive. They use neuroscience research to get you to use them. This is not an accident. And so teaching students how to resist that and plan around that is super important for their success in everything. Like having a conversation for more than a minute with another human, looking them in the eye. And so I have my emails delivered 3 times a day because email is not a time-sensitive thing for me. I have this program that blocks all websites like Twitter and even, the New York Times, because I will do anything to not work sometimes. That part of your brain will just run away from work. And that blocks everything for a duration of time. So this afternoon I blocked it for 6 hours, so I don't get them back until like 9 p.m. tonight, I think. Critical for actually getting work done because I'm a human with a human brain and these websites are designed to take advantage of that. So my day is mixed, I'll keep this short, but is a mix of 3 things since we're a 4-person company. Part of my work is executing on our client work. So I do data science, I write code, I help figure out what, like a lot of times people will be like, we have this problem or we want to know this thing about our users, but we have no idea where to start. And that's our job to figure out where to start. So we talk to them, figure out what their users do, what their business is like, what their goals are, and then we help them translate that into data, and then we write a lot of code to help get answers from the data. Right now we're working with a data set that's 10 terabytes of data, of log data, and we have tomorrow I'm writing a script to sort through that and make some basic graphs so we can just understand the broad strokes of it. And one thing that's been really useful to me is I've learned a lot from people who have modeled not knowing what they're doing. Because every technology I pick up is new to me and they change so fast, working with people who are competent but calm when they're like, there is no documentation for this tool yet because it's so new, how do we go about figuring this out? That's one thing that even if you as a teacher don't have don't have a CS background and are trying to teach programming, that's one huge thing you can model is like not knowing, then what do you do? Because no one knows what they're doing here. We're all making it up as we go along. And modeling that is super useful.
So I'm also a data scientist, so what I do on a day-to-day, I spend a lot of time coding actually. I don't spend a lot of time in meetings, luckily, and I have a good manager who shields me from most of the business systems and lets me just do what I like doing.
Could you take on the challenge of, just in case, what is coding? What does everybody mean by that? What is that?
I get the hard one.
It seems like there's a lot in there. Saying I do that.
Yeah, it's like shorthand for anything essentially.
Yeah.
So what I mean by coding can be very different depending on my task, and so it's probably good to clarify. It can mean just taking a data file and dissecting it, cleaning it out, finding the things I'm interested in, throwing out the things I'm not, and just writing scripts that look for keywords. So just write a simple program that goes through a file and gets all the entries that say Apple or something. Sometimes it can mean taking a whole bunch of scripts and putting them into this big pipeline and making a giant product out of it. Sometimes it can mean staring at the job tracker on our cluster, waiting for my job to finish, and using that as an excuse to not do more important work, like more coding. Like, well, I can't do the next thing until this job runs. What is a job? So if you work in a company that has many people, then often what happens is you on your little tiny laptop cannot actually run your code. You have to get a big supercomputer to do it. And so when you have lots of people and they all want to run on that supercomputer, you have to have some agreement between you who gets to run when and how much of that cluster you get to use at a time. And sometimes you can just be waiting for your job to finish. Sometimes you're just vying for resources, and many of your teachers probably know what vying for resources is like. You probably know what it's like to really want some piece of equipment but have to make some sort of deal with the social studies teacher about whether or not you're going to get that equipment, right? That's what it's like at big companies. We have resources that are limited, especially when we're not Google or Microsoft, but maybe even Google and Microsoft have resource limitations. So a lot of it is navigating those things and understanding, and it's a really important skill, like understanding when your project has to take a back seat to some business interest and it's not personal against you. Lately we have this big project and it's basically driven the rest of us off of the big machines because their projects are so important. So a lot of it is managing business and goals and understanding that your project sometimes will be really important and sometimes won't be important, and it's not a reflection of you as an employee. It's just, that's the way the business direction is going, and being flexible. So lately, a lot of what I've been doing is I was on a project. I had an engineer who was helping me. He had a big risk issue. We had a bug in a product, and he had to respond to that. And in the interim, my project couldn't get done because he then had to go on and work on some other project. And so this project I thought I was going to launch is now a little bit shelved, and I had to move on. And it's sort of, for me, a little bit disappointing. But at the same time, for the greater good of the company, I understand why he had to go fix this bug in this, multi-million-dollar deal with this big-name client, and my little algorithm had to wait. I know a lot of what I do is have to be clever with algorithms, which is my favorite part of my job, is writing algorithms more than anything, because my favorite thing in the world is being clever, and that's what I like doing. People let me do that, I'm really happy.
Tough to go last. Okay, so there's many things there. One is the idea of what is code. So computers are awesome because they do exactly what you tell them to do and nothing more and nothing less. Computers are terrible and frustrating because they do exactly what you tell them to do, nothing more and nothing less. And that is not the world in which we are all evolved to operate in, right? We're evolved to deal in a world of natural languages. Whether you're reading printed word or you're in conversation, it's an incredible fluke that we're ever able to understand each other. Because when you think about the words we use, almost all of them can be read and interpreted in different ways. Our sentences can be interpreted in different ways. It's amazing we have any success understanding at all, given natural language and how ambiguous it is. Right? It'll never work on a computer. Right? So when you work on a computer, you write in a different language, and it is, so to speak, encoded. Right? It's a unique set of instructions that cannot be interpreted multiple ways. Right? Because you want a device that's going to interpret things, or can only interpret things one way, you can't use a natural language. You have to use some code. And that's why we refer to computer programming as coding. And there's an abundance of different computational languages. They're being born all the time for different tasks. You might think that computers are pretty good. Why do we need more languages? As we continue to think about how computation enters our lives and affects our lives and gives us potent powers different ways, we create new computer languages all the time. So there continues to be need for new languages. But if you look at the history of computer languages and coding, you can see how it goes back to more primitive and more machine-like languages, and ultimately it goes back to a point where it's not that different from building a set of gears, so that they only fit together a certain way, right? And in the same way that you build a beautiful watch, the original languages that were computer languages were built very close to the metal, as we like to say, the machine languages. So that's a statement about what is code. And now when we say what is code, you could mean grepping for Apple and multiple terabytes. You could mean anything very high level or very low level. But all of it is written in a language that doesn't sound natural, right? And it isn't natural. Also mentioned, what is your day like? People have mentioned some of these people get to spend a lot of time in meetings. Some of these people get to spend a lot of time making. So I urge you to go look at an essay from about 10 years ago by a computer scientist turned venture capitalist named Paul Graham, an essay called Manager's Schedule, Maker's Schedule, or perhaps it's called Maker's Schedule, Manager's Schedule, and about how very different your career will be, where you have a career where you grow up making and being excellent at that thing, and then your career progresses, and at some point you become in charge of making sure that other people make things excellently in your field. And that is as you transition from a maker to a manager. It doesn't happen to everybody. Some people stay away from it and they stay makers their whole lives. But if you see that your calendar is full of little half-hour blocks, you've become a manager. And if you see that you have a 6-hour block where you just think great thoughts and build, you are still a maker. So people talk about, let me talk about what my day is like. When I tell people I'm a professor, they say, oh, that's nice you teach. Being a professor at a place like Columbia is a very manifold job. There are many attributes and aspects to it. So the students think that my job is to teach. The deans think that my job is to get grants. So I write papers, I mentor students, I get research grants from your tax dollars at work, right? Sort of helping me and my students, push the envelope of what's scientifically possible. I'm also, being a professor also means being a good citizen, helping the university run. So you will find yourself in meetings and doing things that are administrative. Like I've been very active in the engineering school trying to shape an entrepreneurship program. So that takes a lot of meetings, a lot of work, and a lot of working with stakeholders, as we call them, which is another word for people, throughout the university. In my position as chief data scientist at the New York Times, I didn't start out as chief data scientist, I started out as data scientist. So I did a sabbatical at New York Times, which means I went there and I tried to keep my mouth shut and I put my head down and I wrote really bad R code for several months. R is a statistical programming language. And as chief data scientist, on the other hand, I do some of that. So like I spend half an hour a day pair programming with somebody in R. But I also take a lot of meetings. I think today I gave 3 talks and a panel. So like I taught a class, gave 2 talks, and now I'm here. So there's a lot of professing in my day still. Sorry? Some on stage on the stage, sometimes little meetings. Anyways, hopefully not on a stage. So my days are actually very different, and you will probably find that your days are different, and you may find that your career involves a transition from being a maker to a maker and a meter, or a maker, a meter, and a manager, or finally a manager at different points in your career.
I just want to highlight one quick thing, which I think is missed a lot in the stuff that's written online about being a software engineer or working with code, which is that, as you can see, there are a lot of places where being technical and interfacing with people are both really important. And I think there's this misconception in computer science programs that you have to be the best at code, and it doesn't matter if you have no social skills or you don't like people or you like code in a basement, all day and are super pale and drink Mountain Dew. There's that huge stereotype out there. And if you do that, you're just not going to be as successful. And there's a huge role for those people who are well-rounded and who are good with people to have a huge role in the tech industry. And that's also worth highlighting with students who may not fit the mold they see, but that is not the only mold.
At this point, we've got about 15 minutes left, and I just want to make sure that we open it up. What questions do you have for our panel? We can pass around the mic.
Since your stories really inspired me, so I really also is it possible you come to the school and talk to the students and then, inspire the students, when they listen to your story so they know what they should do and then they get more confidence. So is it possible we have a connection?
Yeah, I think actually the way that we found our panel is because I think everyone here is doing that. So that's been the amazing thing about being an educator for me is being in this industry. It's particularly the professionals want to be involved. The professionals are really knocking down the door trying to get into our classrooms, and that's really exciting about computer science. Any other questions? Pass the mic back.
For Sasha, could you talk more about your hack school? You said it was 12 weeks, free, and can you give more detail, please?
I would love to. It's an amazing program. I highly recommend it. It's free. It's 12 weeks. They have an office in Soho. And you basically show up every day, and you are with about 60 other people who love programming. And unlike some programs like Flatiron School and Dev Bootcamp, it's not a boot camp where they take people who don't know how to code and give you basic junior software engineering skills. There are people from all over the place. There are people there who have created programming languages. There are people there who did some sort of international counter-espionage thing that I don't fully understand. He can't really tell me too much about it, but that was a guy in my batch.
Chinese professors. There are people who are Chinese professors.
Totally, and so it's a very heterogeneous group, and you get to work on whatever projects you want. And so this is a major place where I unlearned that thing I said earlier about like doing everything in order. That was a very difficult impulse to resist, but you really can't do that there and be successful. And it was a great model for some of the new trends in in learning, where you don't necessarily hand someone a curriculum, but you hand them a space in which they can find their own way. And that isn't possible in the constraints of some school systems, but it sort of shows what a radical re-envisioning of that educational system looks like. I have given another talk on the educational perspective on Hacker School. I should tweet that out later tonight. Finally put up the slides and tweet that out later tonight. I'd be happy to do that if that would be interesting to you guys. And maybe Yael has something else to add.
So one of the founders of Hacker School, he comes from a background of homeschooling, so this really big like unschooling kind of philosophy. So maybe it's a little bit counter to some of your guys' probably more traditional approaches. But I think it really depends on who you are. So if you're the kind of person who is just motivated by other people's energy to go learn on your own, and there's so many resources out there to learn on your own for free, it seems almost like a waste of money, I'm sorry to say, to go to some of the ones where you have to pay for them. But then again, if you're the kind of person who needs the structure of a school and a program, then yeah, do that kind of thing. I needed something to do during the summer of my postdoc, so I was an independent postdoc, which means that the school pays me to teach undergrads, but then doesn't really give me anything else to do or any resources to hire a grad student of my own. So I had nothing to do for a summer, and I was like, well, this seems like something to keep me focused, and that's how I ended up in Hacker School. A lot of people with PhDs end up in Hacker School. The really great thing about Hacker School is how socially conscious it is. There's a huge focus on inclusivity of really trying to get all of those like subtle, sexist, racist, whatever is things out of the tech world. And it's sort of a little utopia. It's one of the most diverse groups of people I've ever seen in my life. I am in a team of 30. I'm the only woman. I've been there for a year. Whereas at Hacker School, I was one of 30 out of almost 70 people. So it's really one of the greatest places to thrive, especially if you've ever felt like an outsider. So it's hackerschool.org. It's a great place to start.
I have a question. Thanks for coming first.
Take the mic, please.
I'm a teacher. I thought I could just yell. So I'm pretending that I'm in a classroom with my students and you guys are all speaking and nobody asked, but I would ask, what do you do when you get bored or stuck or really frustrated?
So never bored.
If you have like 3 jobs and 3 kids, you don't have the luxury of being bored. And if you get stuck, you often have the opportunity to switch to some other thing. So for example, in graduate school, you get stuck, frustrated a lot. And it's helpful to have a cohort of people. And so getting stuck often involves going to somebody else and telling them what you're stuck on, and it being okay because they've been stuck on other things too. And again, I think something like Hacker School or something like what we try to foster at HTINK, or anything where you create social conditions or a program where everybody's working on things together and they have sort of opportunity for peer learning can be very useful, so that when you get stuck, it's okay to go to somebody else and just bounce idea off them. In software engineering, it's sometimes called rubber ducking. The idea is that you just, by vocalizing your problem, you often get unstuck, or at least gives you new ideas. It's called that because you could be talking to a rubber duck. It doesn't actually matter if the other person is animate. But by having a social environment where people are like incented at least to listen to each other, if not help each other, that can be very useful when people are stuck.
I would like to say asking for help is huge. I think students often think that it's a sign of weakness to ask for help. And it's one of the easiest ways to fail is to not ask for help. So I ask for help like 10 times a day. I don't think it makes me less intelligent or less capable. People ask me for help and I give them help, and I don't think that makes me better than them at the same time. So teaching your students to ask for help, getting them stuck and forcing them to meet other people is a great way to help them learn that skill.
When I was in physics seminars in college, I would be sitting there listening to the professor. This is a 3-hour class where we just read something, and have to talk about it. And I would have no idea what the professor was talking about. And I'd like whisper to the guy on my left and be like, hey, do you know what chapter she's on? And he'd be like, oh. But he's just like sitting there playing cool. The guy on my right, no idea. So I would finally raise my question and be like, what are you talking, where are we? But it made me feel really dumb because I was always the one asking those things, but no one else had any idea either. They just pretended that they knew what they were doing and then like looked later. And that's a really counterproductive culture to have in software engineering where, again, everything changes really fast, no one knows what they're doing, asking for help, and building a culture where you can ask for help and distinguishing that from like cheating and whatever notions students have been handed before about what cheating is. Learning to collaborate is like really the only way to succeed, especially since you can't possibly teach them all the things they need to know out in the real world. They have to keep teaching themselves, and that's the only way to do it. So please, I don't know how to create that culture in the classroom. I would love to hear if some of you have those sorts of ideas. I'd love to hear about that.
Yeah, perhaps the reason why I got into education is because the only times I have been bored have been in school. So basically, I think any situation where I have to listen to one person talk in a room with at least 10 to 15 other people who have to sit and stay quiet, my head starts to like do this thing, and like I really don't know how I have whiplash. Like it's just the basics. I actually felt bad about this, and I tried really hard, and nothing I could do to keep me awake if someone's just talking on and like no one else talks. So if like one person's talking, so I think this applies to meetings too. Sometimes I get bored in meetings when I feel like I don't have like a voice in the meeting. So I try to make sure like all the workshops I do are interactive and engaging. Either like if I'm talking, I try to keep it to a minimal. It's like people have said like that government's best which govern least. I think you can apply that idea to like teaching, right? Like you have to teach something, but the least amount you can teach, the more you can have your participants interact with the content, interact with each other is the better. In terms of getting stuck, if folks have computers or smartphones, go to xkcd.com/627. It's my favorite comic. I teach an intro to computer science class at NYU Poly, and that's in my syllabus. So I really, really stress to my students that they get stuck for 30 minutes before emailing for help. And you'd be surprised how after 5 minutes, 10 minutes, like I think people think that they try for like 5 seconds and doesn't work, and they lose faith. It's like, there's no way I'm gonna figure this out. But like, give it a minute, give it 5 minutes, give it up to a half an hour. Like, I actually like do the opposite scolding if someone spends more than half an hour. It's like, you should ask for help. Like, why did you just spend 6 hours killing yourself over this, right? So it's like kind of a controlled kind of burn, if you will, right? So for 30 minutes, really do your best to try to figure it out. It's kind of like the Pomodoro technique. For 25 minutes, just try really hard to concentrate on one thing. The guy who created that technique because he was doing bad in school, and like he was, as a joke, he's like, is it even possible for me to study for 25 minutes? So like he proved he could, and then went on from there. So yeah, so that's the one.
Yeah, that's that URL. Did you tweet it out to us? Okay.
So you said bored, stuck, and then what was the other one? Frustrated. Yeah, I think it's a synonym in that context. So same applies for that. So, okay.
Baris, you had a.
I want to add one thing. I think being stuck and frustrated is a very beautiful thing. When I first started working, I was frustrated. I would get frustrated that I was frustrated. Like I'd be like, screw this, how am I frustrated and I can't get anything done? But I think throughout time, what I learned is to manage my frustration and to make it more productive. Actually, frustration, I think, in most of the times is the first step to creativity. And getting stuck is also the first step to be creative. I think for students, it'd be great to tell them that being frustrated or being stuck is a very human thing. And they will feel that again and again and again. If they don't feel that, there's something wrong. So they're taking it too easy, right? So yeah, that's
I think it's very important to understand when you're solving a solved problem and when you're solving an unsolved problem. In school, kids are used to being asked to solve solved problems, and like that's just what they do. Okay, you try to find the answer. And one of the things that we're usually teaching kids in computer science, engineering, maker-like classes is that in the real world, most of the problems are unsolved, and you're trying to innovate and solve these novel things. But so in our work, you don't want to waste time figuring out something that the guy next to you knows the answer to. And one of the things that I'm usually counseling are new Googlers who come in thinking that they need to be brilliant and solve everything. It's just like, don't waste time, doing something that you could just turn around and ask a simple question for. But then, you want to spend your time on figuring out, how do I come up with a novel solution to this thing that nobody has ever solved before.
So about 99% of my day is failure, because designing software for humans is really hard. So most of what we design fails. Most of it. I mean, if you have an idea for an interface, you think this is a great idea for some new product or service that you want to offer people, it's probably not a good idea. Probably not. So we spend most of, I as a user experience designer, I spend most of my day failing. And that's actually a good thing, because a failure is something that you've learned. And what's important is that you learn from that failure. You learn what went wrong and how to improve it. And so that's a really, really important thing that I don't think we teach that in school. I mean, it's kind of the exact opposite of how I was educated. It's like, never be wrong. If you're wrong, you're weak, you're a loser. In this field, in my field, you want to be wrong as much as possible, because the more you're wrong, the more you've learned, and the less likely you'll be wrong in the future, and the closer you're getting to something that approximates something that people actually want to use. The other thing is that, at least in the environments that I've worked in, communication is absolutely essential. And if you're ever blocked on something, if you're ever frustrated, you can't get past something, we have what are called stand-up meetings, something probably everyone's familiar with. And every day you meet in the morning and you tell the team what I did yesterday, what I'm doing today, and if there are any blockers, like what I can't accomplish or what is happening that I can't do. And so the first priority after that meeting is to figure out how to get past all those blockers, how to help each other out so that we can move forward as a team and accomplish what we want to accomplish. I think that's a tremendous, tremendous characteristic of the software development industry, and I hope that permeates itself outward to other industries because it's incredibly valuable. So that's what I would try to communicate, is that you're always failing, you're always frustrated. But that's beautiful, because in your frustration, you're learning something new. You don't learn if you just throw an idea out there and it works. You haven't really learned anything. You've just drawn from the knowledge that you already have. You only learn through failures. So that's what I have to say about that.
Can I just add something really quick?
Yeah, go ahead, sir.
I think a really underrated skill is Googling. And I know that from an educator's perspective.
Thanks, Doug.
No, like Google, love it. I use it at work all the time. But I think in terms of an educator perspective, I think it's hard to tell students, like, oh yeah, just Google it. But I think, for me, I just mean, like I said, I struggled with computer science for a really long time when I was trying to learn it. And even through teaching for TEALs, there's some students that understand it when you tell them for the first time. They just pick it up really quickly. And then there's other students just fall really behind that take 10 times longer to understand things. And sometimes you have to explain things in different ways. And there are so many different ways that people explain things on Google. So it's not about finding the answer, but it's about finding different ways that people say it. And as an educator, or even the little bit of teaching that I've done, I don't always explain things in the best way. So it's kind of good for me to also Google ways that other people have taught the same subject. So power of Google is very strong.
Actually, at the Flatiron School, they have a protocol for asking for help, which when we visited the Flatiron School, it was so great that we adopted it for our classrooms. So there's a thing that teachers do. They say, "Ask 3 before me," which is, ask 3 other people before you ask the teacher for help, which is kind of vague. So at the Flatiron School, it's ask 3 before me, but it's Google it, read the error message, and then ask a classmate. And I think that's great that it's concrete, and it's like you do these 3 steps before you ask for help. So we have time for one more question.
I actually have one, because I probably will not get a chance to ask a panel like this question again. I'm wondering, especially in such an emerging industry, what you guys see as the biggest challenges, and then, because I don't want to end on such a negative note, like what do you see would be the solution for these challenges, and is it, and like a time frame? Are we talking 6 months, 2 years, 5 years, 10 years?
Do you mean challenges for the industry?
Yes, specifically for the industry, not necessarily like the challenges of each business that you work at, but the industry itself. Yeah.
So I think something that's really important for our industry is, I think the quality of living, the culture is measured by not how we treat our rich, but how we treat our poor. And software has been avoiding to see poor. We've been building devices, we've been building programs, we've been building software for New Yorkers and San Francisco people. But there exists a world outside of it, and unfortunately, we don't tell these to college students that are studying computer science right now. They're so focused on making the next $1 million or the next $100 million. It's really not about that. There's more to software engineering, and I think our biggest challenge of our industry is the people who are at the top has to see the big picture and tell the big picture to the newcomers in a better way.
I feel like one of the biggest challenges is that this industry is just like constantly evolving. There's always like a new tool that's coming out or some new way of doing something. So I think the biggest thing for me is trying to maintain like a relevant knowledge base of information. And I think the solution to that is just to keep creating sites like Quora and good search engines, Google, Bing, and Stack Overflow is a really big one too. I think continue to post on sites like that so that you can share information to make things really easy to Google. And there's nothing at all wrong with Googling. I know at my job, they're the developers, they've been developing for 10 plus years, and they still have no shame just saying, yeah, I just Googled a solution. So I think just having that information out there makes it easier for the professionals to stay relevant, and for students who might not have any access to a panel like this to have that information. So yeah.
I think to piggyback on one of the previous comments, that the tech industry is really hamstrung by the very narrow range of people who are currently occupying positions of power and influence in the industry, and I think that really shapes what sorts of things they make and how they make them and how they think about them, and how as technology takes over more and more of our life, who makes it and how and why is super important. And I'd love to see that change a lot over the next few years. It's changed a little bit over the last few years, but it still has a really long way to go. I think there's currently a bit of a kerfuffle around Facebook forcing all of their users to use the name that is on their legal ID. That is incredibly damaging to transsexual individuals and is a really destructive policy for those people. And currently Facebook is not being super responsive to that. So it's just one example of how somewhat clueless tech policy can really ruin people's lives and out them and have them lose their jobs and friends and family and things like that. And so it's really important that we get more people into that. And I think educators like you and people who run programs like ScriptEd and TEALS can have a huge impact on that and keeping people who could really make a huge difference in the industry.
I think on top of having a diversity problem, we just have a personnel problem, actually. We can't hire enough good engineers at my company. We pay well. I mean, it's really hard, actually. And I think that's where you guys come in. And it's really, especially since many of you teach inner city schools, you're solving both problems at once. We'll get some diversity and we'll get people, just get bodies. And that's what we really need more than anything. I'd love it if those bodies were more and more diverse. And every time we have, especially in data science, I feel like every time we have more diverse individuals, we get new insights, because so much of data science is about understanding the data. It's not enough to throw an algorithm at it. If you don't fundamentally understand the human behavior that caused that data, you will throw the wrong solution at the problem. And so having diversity really helps that, because it gives perspectives. For data science specifically, there are great people out there who code, there are great people who are out there who are analytical, and there is actually a big chasm of people who can do both. So getting these like quantitative analytical people to also learn how to code at the same time, especially as our entire lives become more and more data driven, that's really important. We're really good at my company at finding one or the other, and it's been really challenging to find someone with that right, unicorn-like set of skills.
As a technology educator trying to prepare young people to enter the fields that a lot of representatives are from, I find there's a huge challenge around technology sometimes advancing faster than education can possibly move. So it's like one group operating like a stealth fighter, the other one operating like a big aircraft carrier, right? So then these things happen so quickly, new trends change, like everyone starts coding in like one language versus the other. Everyone starts using like Git instead of some other version tool. Like things that like, from an educator standpoint, you think are trivial, but then someone gets really tripped up when they can't put the right thing on their resume, or like get biased in their resume because like, oh my God, you're putting on PHP, why'd you put that on your resume? It's kind of like weird, There's kind of weird like challenges that like aren't necessarily inherent to computer science itself, but are just like industry, like nuances and sort of like passions, right? So I think there's a way to like somehow get educators like to be able to do like sabbaticals or residencies in like the industry and have like a stronger education industry partnerships. It's the point of schools should be preparing people to either start their own crypt company or actually academia and be a professor or work for another company, right? So there needs to be better connection, I think, between the industry and education. It's a huge challenge. I see it only getting more diversion sometimes.
Actually, sorry, I just have a quick thing to add. Working for a global company, I work with a lot of technology teams in Mexico and Brazil as well. And since it's an American company, I feel like a lot of the times the systems that we impose on other people are made by us in New York and in London. And when you're trying to impose those systems, a lot of times you have issues with networks because it's just further away, or there are a lot of challenges that you don't really consider. And a lot of times it's just Americans going on business trips to Mexico or Brazil trying to implement these systems while they don't really have the big picture of the idea of what's happening down there. So I'm not really sure. I guess maybe this is just specific to me working at Bank of America for a large corporation, but it's also a lot about culture and how other people do work, because a lot of times there's no right or wrong way, but they take really long lunches sometimes, or they have different religious schedules, or they have different holidays. And as this world is becoming more connected, it's about understanding how other people work and how to incorporate that into your business strategy, and especially into how technology should work with each other. So that's definitely a problem that everyone is going to face going forward.
I think this is starting to change, but we still have a pretty big chasm between the coders and the code nots. Historically, coding computer science was viewed as kind of a niche field. The world needs maybe 3% of the people who know how to code. And I think that needs to change, and is starting to change. Where everybody, it's becoming the new literacy of the current century, where everybody needs to know how to use computers as tools, and coding at various levels. Could be high level, doesn't have to be writing machine code, but in order to do their job effectively. It's great to have all you educators here, because we need to kind of spread the knowledge throughout the whole community.
I think this industry could use a whole lot more humility, to be honest. Working in education, talking to teachers, talking to students, and seeing the struggles that they live through day to day, and then coming back and talking to the people making the software, designing the software, and listening to them preach about how their software is revolutionary and going to change education. Just a quick anecdotal story. It's infuriating. I was developing this tablet application, and it was this revolutionary thing, and everyone talked such a big game about it, and it really was pretty cutting edge technology. All the developers were, yeah, their tech stack is awesome. That's it's not really slang, but it's basically the architecture you use to describe to build your application is really sweet and desirable and work great on a resume. So everyone wanted to work for this company. And we designed this software, and it was targeted to sort of inner city kids. It was a one-to-one tablet initiative, and so much of it was dependent on the kids going home with these tablets and then having access to the internet at home, which is something that many of these kids don't have. Of course, in our great hubris, we completely ignored or completely forgot that you can't give an inner city kid a brand new $300 tablet to take back home to the projects. These schools got these tablets and they were like, this is great, but my kids can't take them home. They're gonna get robbed, or their parents are just gonna steal them. Like, this kid now has become a walking bullseye. We actually even had this like specific case made for the device. It was like bright orange. We're like, thank you. You just made this kid into a walking, robbery target. So I think we need to have some humility. We need to understand, take the time to understand, the people that we're developing the software for. Otherwise, we just seem, I have conversations with people, whether it be teachers or anyone else, people that are using internal enterprise software, and they're like, what planet are you guys on? This is not useful for me. This does not solve a problem I actually have. And you'll go back to the designers of that software and they'll rant and rave about how amazing and revolutionary it is and how it's using this cutting edge technology. I just think we need to be humble and we need more humility in this industry.
I just want to thank our panel for